Hello Year 9. I thought that for the end of this week I would upload a video just helping some of you out with the simultaneous equations. As I've said in our general channel, I was quite surprised that none of you have seemed to have contacted me over this work because it can be quite a challenging topic. One thing that we shouldn't panic about too much is we will be coming back to the topic of simultaneous equations either in year 10 or year 11, and it might be at that point that we spend a little bit of time going over the work that we've covered over the last week or two. So what I've decided to do is go through the simultaneous equation codebreaker task. The reason why I've picked this one out is because there's a variety of different simultaneous equations, some that need more work than others. And this might be turned into quite a long video, but I thought I would go through every single question. I'll work with the top line and I'll work from left to right. And then what you could perhaps do is if there's been one or two that you've struggled with in this code breaking activity, then you can perhaps just skip. I don't know whether I'll be sophisticated enough to do timestamps, but I will skip. You could skip to whichever question it is that you're wanting to do. By watching this video, you'll also get a really good feel for how you should be setting these out in a way that communicates all the steps to anyone that's marking your work. Certainly one thing that I've seen from those people that have been kind enough to upload some images, that explanation with your communication pen hasn't always been there. And like I say, watching this video, you might get a feel for how it is best set out. So we're going to dive straight in. I'm going to jump straight into the first question where x plus y equals 7. And my other equation is x plus 2y equals 12. Now, for those of you that have been looking at my work, you'll find that I always number my equations 1 and 2. And the reason why I always number my equations 1 and 2 is then I can clearly communicate each step that I am doing. So when I'm doing an addition, when I'm doing a subtraction, you know exactly which equations it is that I'm adding or subtracting. Remember, the whole idea of simultaneous equations is there is one solution for x and y that works for both. And your first step is to try and eliminate either the x or the y, find one of the answers, substitute in, get the second answer. So when I'm looking at this one, I can already see that I have got 1x in both of these equations. And when I've got exactly the same with exactly the same sign, they are both 1x, I can subtract those equations. And to make things nice in terms of having a positive number of x, I'm going to subtract this equation, the top equation, from the bottom equation. In other words, I'm going to do equation 2 take away equation 1. Okay? And the reason why I'm going to do equation 2 take away equation 1, you'll see in a moment, that if I do x take away x, that has gone, that has been eliminated. I then have 2y take away a y, and 2y take away a y is just a y. Lovely. And then if I'm doing 2 take away 1, it is 12 take away 7. So immediately I am straight in at x equals 5. And that is half of my answer. So I will underline it. The next process is then to substitute the fact that you know y is 5 into one of the equations and get the x value. And I always try and substitute into what looks the easier of the two equations to substitute into. So I'm going to substitute into the top one. And to make it clear that is what I'm doing, I will write sub in 1. So everyone knows which equation I'm using for the substitution. Okay, so I'm going to do the substitution into this top equation. I don't know what x is, so I'm going to write x plus y. Well, I do now know what y is. Y is 5. So instead of writing plus y, I'm going to put plus 5, and that has to equal 7. And from there, I've got a very, very straightforward linear equation, and you can probably tell me what value x has to be. If I subtract 5 from both sides, x has to be 2. Now, the thing that I really, really like about simultaneous equations is once you think you've got your answer, you've got a way of checking it. And that way, it's another question on your exam or when you're doing some homework that you know is immediately right. And the way that I'm going to check it is I substitute it into my first equation. So I'm going to check using these two numbers and substitute both of those into equation 2 and see if I get something that makes sense. So I'm going to check in 2. So checking in 2, the equation says x plus 2y's has to equal 12. Well, I know that x is 2, so I'm going to write x is 2. I'm adding 2y's. Well, I know that y is 5, so 2 5's, 2 y's would be 10, and it is meant to equal 12. So here I have a calculation, and if that calculation makes sense, I know everything is correct. Is 2 plus 10 12? Well, of course it is. So that's why I put a little tick, just to say I know that my answer is right. So I've now worked out that x is 5 and y is 2, and I could even type that into here. X is 5 and, sorry, that's wrong. X is 5 and y, what did I say? 2. Oh, I've still got it the wrong way around. X is 2, y is 5, that's better. And if I look through and get some letters, where is 2? Probably spot this quicker than me. X equals 2. I. And y equals 5. The answer 5 looks like it is going to be T. Okay, so just like any code breaker, we find the numbers then in our code at the top and write them in. And this hopefully is going to make sense. And yes, it will be a terrible joke, I'm sure. Okay, so that is the first question done. Okay, this next question I'm going to do is the a plus b equals minus 2. And already looking at this, there's a few things that I don't like about it, and there's a few places where we're going to have to be a little bit more careful. Okay, so I'm going to set it up in exactly the same way. A plus b equals minus 2, and a minus 2b equals 1. And again, just as before, I'm going to number my equations 1 and 2. And again, this is an equation where I do not need to do any extra multiplying at any stage. The reason that I can see that is because I have, again, an a in both of them. This a is both 1a, they are the same, I'm going to need to subtract them. Adding won't work because an a add an a would be 2a and it's not disappeared, so I need to subtract them. The more sensible order to do the subtraction in this time is 1 take away 2. And the reason why I'm going to do 1 take away 2 is that will give me a positive numbers of b, but we're still going to have to be careful doing 1 take away 2, as I will illustrate in a moment. So, I'm doing a take away a, and a take away a does disappear, it gets eliminated, that's what I wanted. But now we're going to need to be careful because I have a b and I am subtracting negative 2b. This negative sign belongs to this term. So I am doing b take away negative 2b. Could even write it out if you wanted me to. I'm doing b take away negative 2b. And what you will hopefully recall, that when you subtract a negative, that is equivalent to adding. So when I subtract these two terms, this is actually 3b. The other side of the equation isn't too difficult when we subtract because we are just doing minus 2. Take away another 1, and that is minus 3. So this time I've worked out that 3b is negative 3. So if I want what one of those b's is, I need to divide both sides by 3. So I've now got the solution that b is negative 1. Again, that's half my answer. So I'm going to underline it. There we go. And I'm going to substitute. Now, looking at those equations, definitely it looks like equation 1 is the easier one to substitute into. So again, I'm just going to communicate my step, substitute into 1, and off we go. Well, A, still don't know yet, so I'll write down A. And it says plus B, so I am plussing minus 1. And when you plus minus 1, that is like taking away 1. And that has to equal negative 2. So how do I go about solving this? Well, I need to do the inverse of take away 1. So I'm going to add 1 to both sides. And minus 2 add 1 is minus 1. So A also equals minus 1. Okay, and of course we can convince ourselves with our check. And since I substituted into equation 1, I will be checking in equation 2. So let's see what we have. We have A minus 1. Take away 2 B's. Well, we know that B is minus 1. So 2 B's would be minus 2. But we are subtracting those. So when we are subtracting 2 of those, okay, it is like minus 2 lots of minus 1. And it's going to be, again, another place where that is equivalent to adding. So it ends up being minus 2 plus 1. Sorry, minus 1 plus 2 equals 1. Is minus 1 plus 2 equaling 1? It certainly is. Both of those answers are right. Okay? Now, for me, I probably don't need to do these check stages because I'm going to be confident that I've got these 2 steps right. I will have my 2 parts correct. But for you, doing these checks is incredibly important to convincing yourself that your answers are right. So, I've now worked out that A is negative 1, B is negative 1. What letters do we get for those? That is O and O. Okay, let's continue to move on. So you can see it's taking me about 6 minutes per question to explain in detail. This video could go on a while. Okay, moving on to the next one. So, solve the simultaneous equations below. Let's just get a little bit more room. We've got P plus Q equals 7. And we have 4P plus 2Q equals 23. Okay, now this is the first equation where my number of P's or my number of Q's are not the same. So neither adding or subtracting these equations is going to make something be eliminated. Okay, I need the number of P's or the number of Q's to be the same. So what I think I'm going to do is I'm going to multiply this top equation by 2. And that way I will then have the same number of Q's. So again, I'm going to communicate that by just saying I'm going to times that one by 2. I'll write it underneath. That times 2 is 2P. This times 2 is 2Q. And don't forget the number on the end needs multiplying as well. 7 times 2 is 14. Multiplying an equation by a number, as long as you do it to every single term, will not affect the values of P and Q. Okay, and again, since I've created a new equation, I'm going to number that one number 3 so I can communicate what I'm going to be doing at the next step. These number of Q's are the same, So to get those to eliminate, again, it is another subtraction question. So I'm going to do equation 2, take away equation 3. So working this through, it is 4p, take away 2p's. That is 2p's. The 2q's, take away the 2q's, is eliminated. So that has gone, that's what we wanted. And 23, take away 14, is 9. Okay, so 2p is 9. To work out what 1p is, I'm dividing by 2, and that is 4.5 or 4.5. And you might recall that I did say that in simultaneous equations, quite often we would have integer answers, but maybe things like a fraction of a half is fine. If you get a really horrific decimal, that is always a dead giveaway that something has gone badly wrong at some stage. So, p is 4.5. I'm going to substitute that in to the top equation, and we'll see what we get for q. So let's call this substitute into 1. So I know that 4.5p plus q equals 7. So to work out the value of q, I'm going to have to subtract 4.5. And 7 take away 4 is 3. Take away the extra half is 2.5. So q is 2.5. So I found my two answers. Let's do a check. And I'm going to check in my equation 2. So I'm going to check in 2. Now, hopefully you wouldn't need a calculator here. I need to do 4 4.5s. Well, I know 2 4.5s is 9, so 4 would be 18. I have q is 2.5, so 2q's would be double that, so that's 5. And it is supposed to equal 23. Is 18 plus 5 23? Yes, it is. And I'm convinced that that is right. Okay, so I've now worked out the values of p and q. 4.5 for p. 4.5, let me just type that in. 4.5. And q is 2.5. So again, if I scroll back up, I can see that k is 4.5 and 2.5 is a. So k and a. Okay, I think what I'm going to say, Year 9, is I've gone through 3 of these and we're just over 18 minutes. I'm going to wait and see if this has proved helpful to people. Do you want me to go through the other half of this task? And if I get enough people saying yes, sir, it's been really, really helpful, then I will upload a second half of this video. So we'll call this part 1. If people aren't that interested, people have managed more than I would give you credit, then I won't do a second part. So for the time being, it just goes for me to say, do keep in touch. Not had too many emails. I'd really like to hear from you. Try and upload some work to Teams so I can actually see how you're doing. Those are the students that I've been able to help out the most. But for the time being, signing out and goodbye.